Now let's continue our discussion of prime numbers and prime factorizations and try and utilize the theorems that we went over to determine if a number is going to be prime or composite. So what if somebody would say to you, hey Tim, you're a math guy, what's the smallest prime number bigger than or equal to 1,000? I should be able to figure that out, right? Well, guess what? So should you, because of the theorems that we have discussed. Let's review the last theorem that we were going over. If I have a composite number n, or n is a whole number bigger than 1, I know that 1 and n are going to be factors of n. If it's prime, those are going to be the only two factors. However, if we come all the way to the middle, and we have the two innermost ones, if that actually is the same number, it would be the square root of n times the square root of n. So all I've got to do is check the prime numbers less than or equal to the square root of n. For example, we were looking at 36. 36 is 1 times 36. If 36 is composite, the square root of 36 is 6. Now 6 times 6 is 36. So the square root of it, all I got to do is check prime numbers less than or equal to the square root, or in other words, less than or equal to 6. So all I have to do is check prime numbers less than or equal to 6, which would be 2, 3, or 5. If any one of these divides 36, then 36 will be composite. If none of these three would divide 36, then 36 would be prime. But of course, 2 is less than the square root of 36, and it divides 36, so we know that 36 is a composite number. But it really restricts, instead of looking at 36 numbers or the 34 that are in between 1 and 36, all we have to do is check the primes less than or equal to the square root. If one of those divides it, then it will be composite. If none of them do, it will be a prime number as long as n is bigger than or equal to 1. So let's look for the smallest prime number bigger than 1,000. We don't want to say the biggest prime number bigger than or equal to 1,000 because there's infinitely many prime numbers. Means prime numbers continue on. We can get bigger and bigger and bigger prime numbers. That is a theorem that I've had that's not in your book. Okay? But if we start with 1,000, is 1,000 prime? No, because it's divisible by 2. So it's pretty easy to eliminate that one. The question is, what if I'm looking at 1,001? Is that divisible by anything? Once again, there's 999 numbers strictly in between 1 and 1,001. That old school method, we're not going to want to spend that time checking all those out. So what I'll do is I'll look at the square root of 1,001. And if you do that, maybe have your calculator handy, you're going to see that that's about 31.63, etc. Or basically, all I've got to do is check the prime numbers less than or equal to 31, and if that ends up, one of those divides 1,001, it will be composite. So let's list out what those prime numbers are. I'll do this here because we're going to reference them again, but the prime numbers 2, 3, 5, 7, 9's not, 11, 13, 17, 19, 21's not, 23, 25's not, 27's not, it's divisible by 3 or 9, 29 is, 31 is, and if we need them, we can keep going. But for right now, the primes less than or equal to the square root of 1,001 are these primes, so instead of checking 999 numbers, I've got 5, 10, 11 numbers is all I got to check. So once again, you can have your calculator handy, but what we're going to find out is that 1,001 is actually going to be, first of all, it's not divisible by 2, it's not divisible by 3 with those divisibility tests, not divisible by 5. 7, you can try out, it's not going to work. We do have a divisibility test for 11. Remember, if you take the sum of the digits in the even powers of 10 minus the sum of the digits in the odd powers of 10, we're going to end up with 1 minus 1, which is 0, which is divisible by 11. And so that means that 1,001 is divisible by 11. And in fact, when we divide it by 11, 1,001 is actually 11 times 19. So it's also going to be divisible by 19. So you can verify this on your calculator. So 1,001 is out. Of course, 1002 or any even number is going to be out because it's going to be divisible by 2, so I'm going to ignore those. Let's just check the odds going up. Let's look at 1003. Well, we can go through the same process, use our divisibility test by 2, 3, 5, 11, 7 we'll have to try out. What we're going to notice, 13 doesn't work either, but 1003 is divisible by 17, and you're going to end up with 59. So 1003 is out. Let's go to 1005. What can you tell me about 1005? Is it prime? No. It's divisible by 5. Okay, that would actually be 201, but it doesn't really matter. It fits our divisibility test. So, since it's divisible by something other than 1 in itself, it's composite. What about 1007? Surely that has a chance. But as you continue on, once again, the square root here is still 31 point something. We're not breaking 32 yet, but 32 is not prime anyway. Neither is 33, neither is 34, neither is 35 or 36. So we're safe just checking these primes less than or equal to the square root of these numbers so far. We're going to have to get pretty big to get past there. But anyway, 1007 is actually divisible by 19, and if you divide that, you'll get 53. So what does that mean? 1007 is composite, and it's not going to be a prime number bigger than or equal to 1000. So when we get to 1009, we notice that 1009 will not be divisible by any of these prime numbers, and these are the only prime numbers less or equal to the square root, because the square root of 1009 is still in the 31s. It's about 31.76, etc. So all I've got to do is check the primes less than or equal to, say, 32. These are the primes. Once again, there's only 11 numbers I need to check. And none of those divide 1009. None of these primes, green primes, divide 1009. So therefore, 1009 only has divisors of 1 in itself. And that means that 1009 is prime. So I challenge you to maybe try this with 100 or 2,000, etc. So just pick a number, or 500 might be one. Try and find the smallest prime bigger than or equal to that number utilizing the theorems that we've learned in this section.